Today we're going to do the projectile motion problem. In this particular problem, as we can see, a cannon fires a ball at 10 meters per second at an angle of 36.9 degrees from a height of 27 meters above the canyon floor. Alright, here we go. First step we want to do is we want to look at the initial velocity of the whole situation. So in this case in particular, it says that the cannonball was launched at an angle of 36.9 degrees at 10 meters per second. So this gives us the initial velocity. So if I draw the initial velocity here, this is my initial velocity and it's equal to 10 meters per second. Now, if this is a 36.9 degree angle, I know that's up and to the right, so the question is, can I figure out how much of it is to the right and how much is up? So if I break this up into its component parts, here's the horizontal component. We call that the Vx, that's the horizontal velocity. And then I also have the vertical velocity component. And we're going to call that V0y. So how am I going to get those? Well, one of the things that we know from our general study of mathematics is the definition for the sine of an angle is equal to the ratio of the opposite side to the hypotenuse. If I apply this to this case, the sine of 36.9 should be equal to, now what is the opposite side here? We can tell that the opposite side here must be equal to the V0y, and the hypotenuse here is our 10. Multiply both sides by 10. V0y is equal to 10 times the sine of 36.9 degrees. Bust out your handy dandy calculator and you realize that the V0 in the y direction is equal to 6 meters per second. We can apply the same concept with the horizontal, except for in the horizontal, it's the cosine of my angle is equal to the ratio of the adjacent side to the hypotenuse. So in this case, the cosine of 36.9 is equal to the adjacent side, that's the next to side, the Vx over the hypotenuse is 10. Multiply both sides by 10. The velocity in the horizontal direction is equal to 10 cosine 36.9, and the v in the x direction is 8 meters per second. So where do we go from there? Well, once we have the V0, or the Vx, which is 8 meters per second, and the V0y, which is 6 meters per second, we can answer this next question, which is what is the maximum height above the cliff? What is the maximum height above the cliff? All right, so the first thing we have to do is make some space. Let's get rid of this. How are we going to find the maximum height above the cliff? Well, one thing about this problem is that the ball, once it leaves the cannon, we'll take a parabolic path thusly. And we want to know what is the maximum height above the cliff here, which we'll call h. We know that we can break the problem up into its horizontal and vertical pieces. So in this case, we only need the vertical piece. So if I think about the vertical part of this, the thing that's important is at the maximum height, the velocity in the y direction is equal to 0. So if I break this down, velocity in the y direction is equal to gt plus the initial velocity in the y direction. If I said this equal to 0, this is negative 10t plus the initial velocity in the y direction is 6. I end up with t is equal to 0.6 seconds. Now, that gives me the time. Can we figure out the height? Sure. I'm just looking for the change in the position. It's equal to 1/2 gt squared plus v0yt. So if I want to find the change in the position, negative 5 plug in my time over here, 0.6 squared plus 6 times 0.6. Do a little math on that one, and it turns out 1.8 meters. Now that's the change in position, so it's the change in position between the initial height and how high it is. So 1.8 meters is your answer on that one. The last question says, at what horizontal distance will the ball hit the canyon floor? Well, in order to do that, we have to use both the horizontal and vertical components. So if I break this down, if I say, okay, well, here's my ball, it's going to go out and come down, right? We need to figure out what the horizontal displacement is. We'll call that the change in the horizontal position. So we allow this problem to exist in both the horizontal and vertical parts. So let's do the vertical first. The change in the position is equal to 1/2 gt squared plus v0yt. We know that the ball has to drop 27 meters, so the change in position is -27, -5t squared plus 6t. Add this to both sides. Now, here you can factor, or you can divide through by -5 and then factor. Either way, so what we'll do is we'll divide out a -5, so t squared minus 1.2t minus 5.4. Now this might not seem obvious, right? And I would use your calculator to solve this. T, I have 3 and I have 1.8 minus positive, and so we can see t is equal to 3 seconds. So this gives us the vertical component here. And once we have the vertical component, then we can go back and look at the horizontal component to see how far it goes. We know that in the horizontal direction, delta x is equal to vxt. These equations are slightly different because this is a constant speed equation. We know the v in the x direction is our original 8 meters per second times 3 seconds. So the delta x is equal to 24 meters. So this traveled 24 meters in the horizontal direction before hitting the ground.